Greetings. We're on Chapter 9, Rational Expressions. Today we're going to look at Section 9.3. We're going to obtain the lowest common denominator. So the least common denominator or the lowest common denominator, the LCD, and this works as with fractions. Basically, we're going to factor the denominator of each of the fractions and then look for the least common multiple between all fractions, which we'll then use as the LCD. Then we're going to rewrite each fraction with that new LCD. So what we're going to do first is we're going to start looking at and finding what the LCM is, least common multiple between fractions. So basically what we've done is we've taken the fractions and we're just looking at the denominators here. So we have 3 denominators. Here we have 2 denominators. And what we're doing is we're just looking for the LCM. And so what we have to do is we have to factor each of these and then kind of look and compare them together. So our first one is x squared minus 3x. And we can factor out an x, and that leaves us with x minus 3. Then x minus 3, well, that's just x minus 3, and x is just x. And so we're going to use each term the most times in one item. And so really what happens is this is going to be our LCM because we have x minus 3 here and here, so it's going to be used once. We have x here, and it's at most once. We're going to use that. And so our LCM is going to be x times x minus 3, and when we get done doing it, we can multiply it back out and we'd get our x squared minus 3x, but most of the time we're going to leave it like that, so when we get done putting it back into the fractions and then doing the addition or subtraction it's asking us to do, then we can reduce if necessary at the end, so we still have it in a factored form so we don't have to refactor it again. All right, so let's look at these. So we have 5x squared y. Well, that's going to be a 5 times an x times a y. And then we have the 25x cubed y to the 5th times z. And so that's going to be 5 times x times x times x times y, and then a z. Okay. So looking at this, we have 1 5 here and 2 here. So we take the most times it occurs in one factoring. So our LCM is going to be 5 times 5. Now we have 2 here, but we've got 3 here. So then we'll take times x times x times x. And we only have 1 y here, but we've got 5 here. And I think I'm just going to write that y to the 5th. And then we have z here. And so our LCM is really just going to be 25, x to the 3rd, y to the 5th, z. And so that's what our LCM will be. And then what we'd have to do if we're going to go back in and change our fractions, we'd have to multiply each of these times whatever it was we needed to get to this as our LCM or our LCD at that point. Okay, so looking still more at LCMs. Before we go, looking at x minus 7 and x plus 1, none of those can be factored. And so our LCM is just going to be the things in common. Well, here we're going to have x, then we're going to multiply that by x minus 7, and then we're going to take that times x plus 1 because that's in one time in this one, that's in one time here, and that's one time here. And so we take each factor, the most it is in each term, and so that really is our LCM. Now again, we're going to leave it in the factored form. That way when we get done, if we need to, we can reduce because it's already factored. All right, so the next one is a little more difficult because we actually have to do some factoring of trinomials. So we have x squared minus 7x plus 10. And so we think about that. Well, that's going to be x and x. And then 2 factors of 10, it has to be negative because it's going to be a positive here, but we need the negative here. And if we think 2 factors of 10 that multiply to 10 but add to 7, that would be a 2 and a 5. Because 2 times 5 is 10, and 2 plus 5 is 7. So that's the factoring there. Now, x squared minus 2x minus 15. All right, so again, we're going to have x and x. Now we're going to have a plus and a minus to get that negative there on the end. And we know the larger one is going to be negative. So what 2 factors of 15 multiply to 15, but when you subtract them, you get 2. Well, that would be 3 times 5 will give us 15, and 5 minus 3 will give us 2. So the larger is negative, the smaller is positive, and that would be our factorization there. Now if we have x squared plus x minus 6, well here, we're going to have again x and x. This time it's a negative here, so it's going to be a plus and a minus. And this time the larger one is going to be positive. And so what two things multiply to 6, but when we subtract them we get 1? Well, that'd be 3 and 2. We need the positive one to be larger, so 3 and 2. And so that's how we would factor that one. So now our LCM is going to be the number of times it's a factor, well, in each term. So this one has x minus 2 once, and it has it once here. So it looks like x minus 2 is just going to be one time. Then we have x minus 5 once, and so again, x minus 5 is one time. Then we have x minus 3, only once here, so we'll have x minus 3. And then that looks like all of our terms that are possible, and so our LCM is just the product of those three binomials. All right, so along those same lines, finding the equivalent numerator. So what we have to do is we have to look at the denominator here and the denominator here and see what did we do. Well, going from x to x times y, we multiplied by y. So that means we're going to have to take and multiply by y here. So our question mark is going to be equal to a times y. Okay, and that's how we got to that, because we knew we had to take x times y to get the xy, and so we have to take the same thing by the numerator, and that would be the y here. Now this one we have to kind of look at and say, well, what is that really? Well, that's a difference of squares, so that's going to be x plus 4 times x minus 4. So we start with x plus 4, and then we have the x plus 4 still there, but we've multiplied by x minus 4. So in the denominator, we multiplied by x minus 4, so that means we're going to have to take this times x minus 4 as well. So the question mark is going to be 2 times x minus 4. Now, if they want us to, we can go ahead and multiply that out, and all that means is we distribute here, and that'll get us 2x minus 8. Okay. So that would be what our solution to this one would be. All right, some more here. What do we have to take? And what we're going to do is we're just going to look at each individual item and see what we had to do to multiply by. So we start with 3 and we end with 9. So that means we're going to have to multiply by 3. So we're going to multiply by 3. Now we have a to the 5th to a to the 5th. Well, that's the same, so we didn't change that. B squared, we didn't change that. C to the 4th to c to the 4th, we didn't change that. So all we really did was we just multiplied by 3. And so if we take 4 times 3, that means our question mark, our numerator, is going to be 12. Okay. Now the next one, again, we're going to have to factor because we have a trinomial. We don't know what that means. And I'm going to say, well, it's going to be x plus 3 because I started with an x plus 3, so I better have an x plus 3 here. And then I'm going to have x what? Well, I know I have to have a negative, so that's a minus. 3 times what's 15? 5. If I have a minus 5 plus 3, it's a minus 2, so that looks good. So my x plus 3 is okay, so all I'm going to do is multiply the numerator times x minus 5. And so then my question mark is going to be x minus 6 times x minus 5. And again, they're going to want us to multiply it out because this is multiplied out. And so I'll do the FOIL, x times x is x squared. And then I'll take first times last, so it's a minus 5x. Then the inner is minus 6x, so minus 5x minus 6x, well, that's a minus 11x. And minus 6 times minus 5 is going to be a plus 30. And so that then is going to be my numerator, because what I had to do is I had to multiply both numerator and denominator by x minus 5 on this original rational expression to get that denominator here, and so I also have to do it in the numerator there. All right, so here what we're doing is we're finding the LCD, and then we have to rewrite each of the rational expressions with that new LCD. So if we look here on our two rational expressions, we have an x minus 3 and an x plus 2. All right, well, neither one of those can be factored, and so our LCD is just going to be each of those factors, x minus 3 times x plus 2. Okay. And so that's the LCD now. And so what we have to do is we have to rewrite each of these rational expressions with this LCD. So if we have x plus 2 over x minus 3, well, what did we have to do here? We had to multiply the denominator by x plus 2, and so we also have to multiply the numerator by x plus 2. Now, if we wanted to go ahead and expand that out, we're going to take x plus 2 times x plus 2, and that's going to be basically a perfect square. So that's going to be x squared plus 4x plus 4, because you're going to have x times 2 is 2x, then we have another 2x, so that's 4x, and then the 4 there. And here we're going to have x times x is x squared. Then we'll have plus 2x minus 3x, so that's going to be minus x, and then that's going to give us a minus 6. And so that is going to be the first rational expression rewritten with the new LCD. Now the second one, we have x minus 3 over x plus 2, and we had to multiply by x minus 3 here, so we're going to take x minus 3 and x minus 3. Now the denominator, we already know what that is because we multiplied it there. That's x squared minus x minus 6. And the numerator is another perfect square. So we're going to take x times x and get x squared. Then we have minus 3x, so that's a minus 6x. And minus 3 times a minus 3 is plus 9. And so that is my second rational expression rewritten with the common denominator. And notice they both have the same denominator now, and we've just updated their numerators by multiplying to get that common denominator. All right, now we have two rational expressions, fractions, and we have to factor each of their denominators. So on the first one, that's a perfect difference of squares. So it's going to be x plus 6, x minus 6, because if you take 6x minus 6x, that's 0, and then you have your minus 36. And then the second one is a perfect square. That's x plus 6, x plus 6. And so that's the second one here. So our LCD then is, well, we have x plus 6 once here, but we have it twice here. So it's going to be x plus 6 times x plus 6. And then we have x minus 6 here, not there, so then we'll have an x minus 6. Okay. Now this is one where we might actually not multiply it all out, because you're going to have, to multiply all three binomials here for your LCD. And a lot of times they'll say, just leave it in factored form. That way you can show that it hasn't been, you can't reduce anything. And so if we do that, what do we have to multiply this first one by? So we start out with x plus 1 over, and then let's go ahead and write that in factored form. What do we have to multiply that by to get the common denominator we found here, the LCD? Well, we have x plus 6, x minus 6, so we have those two end ones. So we have to multiply on the denominator an x plus 6. So whatever we do down there, we have to do up there. And so then if we write it out in factored form, that's x plus 1 times x plus 6 all over x plus 6 squared times x minus 6. And we're writing the squared because we have two of them, so I'm just going to write squared instead of actually writing both of them out again. And so that would be then my factored form. And again, you could write it out with all three terms like this, or the two terms with our squared power. All right, what about the second rational expression? We had 2x plus 3 over, and then we had x plus 6, x plus 6. Well, we have to multiply this one by the x minus 6, because we have two of those, and so now we take it times that last term, the x minus 6, and what we do in the numerator, our denominator, we have to do in the numerator. And so we get in the numerator 2x plus 3 times x minus 6 all over, and then we have our x plus 6 quantity squared times x minus 6. And again, this would show that we couldn't reduce it. Now we can reduce it, but what we're wanting to do is we want to get it to the point where now what we could do is we could add these two together, we could subtract them, whatever it asks us to do, and then at that point we would have to simplify the numerator and then keep our denominator as a factored form. And then once we have multiplied that out, added it, then we have to factor the numerator and go from there. So right now we're just looking at finding the LCD and then rewriting each of the rational expressions with that new LCD. All right, looking at this first one here, really all we have is x minus 4 in one, x plus 2 in the other. We can't do anything with those as far as factoring. So our LCD is just the x minus 4 times the x plus 2. Okay, well, what does that tell us for the first one? Well, we have 3x over x minus 4. What do we have to multiply by that denominator to get the LCD? Well, we have to multiply by x plus 2. So what we do down here, we also have to do up here. And so that gives us 3x times x plus 2 all over our LCD of x minus 4 times the x plus 2. Now, in our second rational expression, we have 2 over x plus 2. So this time we just have x plus 2, so we have to multiply by the other term, the x minus 4. And again, what we do down there, we do on top. And so that gives us 2 times x minus 4 all over x plus 2, x minus 4. Okay, so now we have the common denominators, and then if they wanted us to add these two rational expressions or subtract them, we could do that with no problem. We have to simplify their numerators and then factor those out and see if anything would cancel out in the end. Okay, what about the next one? Well, again, this trinomial looks like we can factor it. And so we're going to have an x, we're going to have an x, we're going to have a plus, and we're going to have a minus, and the larger one is going to be negative. So what two factors of 10, if we subtract them, give us 3? Well, 5 times 2 and 5 minus 3, or 5 minus 2 is 3. So the larger one has to be 5, smaller one has to be 2. And so now we've got an LCD easily visible here, and it's going to be x plus 2 times x minus 5, because we have x minus 5 in both, and then we also have an x plus 2 here. So if we rewrite the first one with our LCD, well, guess what? It's already written as that with the LCD. It's just 5x plus 1 over, and then we have x plus 2 times x minus 5. So that one's done. We don't have to do anything because its denominator was already the LCD. Now the other one, though, we have 4 over x minus 5. So what do we have to multiply to get that LCD? Well, we have to multiply by x plus 2. And so again, what we do in the denominator, we have to do in the numerator. And so that gives us 4 times x plus 2, and then x minus 5, x plus 2, and then that would be our final thing. Again, if we're adding or subtracting these together, we'd have to go ahead and distribute here, then add the numerators, and then factor at the end to see if anything would cancel numerator and denominator. All right, what about this one? Well, this time we have 3 rational expressions, so that means we have 3 denominators we're going to have to factor, and then our LCD is probably going to be larger. It might be 3 terms, maybe more. So on our first one, let's just write them down here, x squared minus 6x plus 8, and that's going to be, well, we're going to have an x and an x, and we're having a minus, and 2 factors of 8 that add to 6, well, that's 4 and 2. Okay. So that would be our first trinomial factored. What about x squared plus x minus 20? Well, again, we're going to have x and we're going to have x. Now one's going to be plus, one's going to be minus. Oops. Well, okay, minus 2. And I'm already thinking ahead here, but I don't think that's the right number. I don't know why I wrote minus 2 because I was looking ahead of above it, I guess. And so now 2 factors of 20 that add to or subtract to get us 1, but multiply here, well, that's going to be 5 and 4. And so the larger one has to be positive, 5. Smaller one has to be negative, 4. And then that's going to be the factorization of that one. Now the last one, x squared plus 3x minus 10. All right, so again, we're going to have 2 binomials. We're going to have x and x. Now this is negative, so one's going to be positive, one's going to be negative. And here, 2 factors of 5 that subtract to 3. Well, that's going to be 5 and 2. And the large one has to be positive, so that's going to be 5. That's going to be 2. And so now we can get our LCD. Our LCD is going to be, well, we only have 1 x minus 4 here, 1 here, no doubles. We have 1 minus 2, no doubles. We have 1 plus 5, no doubles. And so it's just going to be x minus 4, x minus 2, x plus 5. And so that's going to be our LCD. Now what do? Well, now we have to rewrite each of these with the new LCD. So that's 3x over, and that was x minus 4, x minus 2. And what do we have to multiply that by? Well, the other term is the x plus 5. And so we do that on the numerator and the denominator. And so it's going to be 3x times x plus 5 all over our LCD of x minus 4, x minus 2, x plus 5. Okay. Now let's go to the next one. So our next one, what we have is we have x minus 2 over, and this was x plus 5, x minus 4. And so we had to multiply that by what? Well, the other term is x minus 2. So x minus 2, x minus 2. And so what we have is x minus 2 squared over x plus 5, x minus 4, x minus 2. So that's the new one here. And again, that's a 2. And then our final one we had is 5 over, and that was x plus 5, x minus 2. And, oh, not equals, but multiply. And so what do we have to multiply by to get that one? We have 5 and 2, so that means we have to multiply by the x minus 4 in the denominator and also in the numerator. And so that gives us 5 times x minus 4 all over x plus 5, x minus 4, x minus 2. And so those then would be our 3 rational expressions written with the common denominator. And then what depends on what it has us do after that. If we actually had to do something, we'd have to distribute here and FOIL here and distribute here. And then if they had us add, subtract, multiply, or add or subtract basically, then we'd have to go and do that there. All right, so that's all I have for this section. Hopefully that will help you.